In section 3.2, we developed a library of parent functions where we examined an overview of different categories of functions. In the next 3 sections, we're going to focus on a single type of function per section and drill down on the more granular details and properties of each function. We'll begin here in section 3.3 with linear functions. One aspect that we can use to describe a line is its slope. The slope m of a line containing 2 points, x sub 1, y sub 1, and x sub 2, y sub 2, is a measure of the steepness of the line, calculated as the ratio of the vertical rise to the horizontal run. If we look at our diagram here, the vertical rise between the 2 points is this vertical segment right here, and we could measure the distance of that segment by taking the difference in the y values. This would be calculated y sub 2 minus y sub 1. The horizontal run is this horizontal segment right here, and we could measure that distance as the difference in the x values, x sub 2 minus x sub 1. So we define the slope, which we generally denote as m, as the ratio or the fraction containing the vertical rise in the top and the horizontal run in the bottom. So this generates the formula m equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Now, if we have a graph, we can visualize the rise and the run and easily calculate the slope. On example 1, we want to determine the slope of the following lines. To find the slope from a graph, we want to locate 2 points on that line that land right on the crosshairs of the grid. That way we can precisely identify the xy ordered pair for those points. So I'm going to choose this point right here located at 0, negative 2, and this point located at 2, 0. Then we're going to measure the vertical rise and the horizontal run between those 2 points. So the vertical rise would be the length of this segment right here, and clearly we can see that's a distance of 2. The horizontal run is the horizontal segment. We can see that's also a distance of 2. So our slope m will be calculated as the ratio of rise 2 to run 2, and this reduces to 1. So this line has a slope of 1. Notice when we calculated the rise, we were working up. We calculated the run, we were moving to the right. A slope that slants up and to the right always turns out to be positive. Let's take a look at the next example. So again, I want to choose 2 points that are clearly on the crosshairs of the grid, and you can choose any 2 points with those properties on the line and calculate the same slope. I'm going to choose this point at 0, 3, and this point at 1, 1. And we want to measure rise over run. Notice in this case, when we measure the rise, we're working in a downward direction. So we would say this is a rise of negative 2 or a descent of negative 2. We're always going to run to the right, and we can see here the difference between those two x values is 1. So our slope m, calculated as vertical rise, negative 2, to horizontal run, 1, we could simplify to negative 2. So a line that slants down and to the right will always have negative slope. Examples C and D are just a little bit different, so let's examine horizontal and vertical lines. You can choose any 2 points on this line. I'll choose the point negative 2, negative 3, and the point 2, negative 3. The slope is still going to be calculated as the vertical rise to the horizontal run. Now notice between these 2 points there's no vertical difference. So the rise is 0, but I can tell that there is run between these 2 points. Clearly it's 4. 0 divided by 4 is equal to 0. Notice anytime you're dealing with a horizontal line, the slope will always be 0. Let's contrast this with the vertical line. We can choose any 2 points on this vertical line. I'm going to use the point 2, 2 and 2, negative 2. And we want to calculate rise divided by run. So in this case, we do have rise. The difference between those y values is 4. but we don't have any horizontal change between those 2 points. So our horizontal run is 0. Now, as you know, we cannot divide by 0. 4 divided by 0 is an undefined operation. So we say that the slope is undefined. The slope of a vertical line will always be undefined. So we've got all 4 possibilities with these 4 graphs. We have an example of positive slope, negative slope, 0 slope for a horizontal line, and undefined slope for a vertical line. Let's see if we can calculate the slope without looking at a graph, just given a set of ordered pairs. On example 2, we calculate the slope of the line that passes through the 2 given points. Now, you can order your points in either order. I'm just going to call the first point, point 1. So we have x1, y1 here, and we have x2, y2 here. If I transposed those 2 points, I would actually end up with the same slope. So remember, the formula for slope is the difference in y values, y sub 2 minus y sub 1, over the difference in x values, x sub 2 minus x sub 1. Plugging in our values, we have y sub 2, which is negative 7, minus y sub 1, which is 5, x sub 2, negative 3, minus x sub 1, minus 2. So we end up with negative 12 divided by negative 5. Or when we simplify, our slope would be positive 12 over 5. We'll apply the same process on example B. Let's consider that first point to be x1, y1, and the second point, x2, y2. Now, I've already got my slope formula over here. So with that in view, we're going to plug in negative 1 for y2, and we're going to subtract y1. Notice y1 is also negative, so I've got a pair of negative signs there. We'll simplify that, of course, on the next step. In the denominator, we're going to calculate the difference in the x values. So we take x sub 2 minus x sub 1. When we subtract a negative, that's the same thing as adding. So we have negative 1 plus 1 in the top. 3 minus 2 in the bottom gives us 1. So notice our slope is 0 divided by 1, which is equal to 0. So it must be the case that we are dealing with a horizontal line. Observe from the given points, both points have the same y values. This means they have the same elevation. They have different x values, but the same y values. So clearly that is a horizontal line. Okay, one more. Let's call the first one x sub 1, y1, x2, y2. And we'll calculate the slope as the difference in y values, y2 minus y1, over the difference in x values, 5 minus 5. So this gives us negative 1 over 0. And there we have that 0 in the denominator again. This is an undefined operation. So we say the slope is undefined. That must mean the line that we're dealing with is a vertical line. And when we take a glance back at the ordered pairs, notice both ordered pairs share the same x value. So they have the same x value, but each point has a different y value or a different elevation. So clearly those belong to a vertical line. So that's how we calculate the slope of a line between 2 points.